We're back. We are continuing and we're jumping into combinations of functions for section 5. For this, I'm trying something new. I'm trying to give you some guided notes so that you don't have to write as much. So it's up to you if you want to print them and put them in your notebook or put them in a separate file on your tablet or computer and try to annotate over them. It doesn't matter to me. You can even take them the old-fashioned way. Just trying to help you make some better use of your time while we're doing these notes. So anyway, go ahead and get those ready, whatever it is. But you will be turning these notes in that you do take with the rest of your notes from chapter 5. Okay, so let's talk about combinations of functions. So we can take a sum, a difference, a product, and a quotient of functions. Hopefully this looks very familiar to you from algebra, maybe even pre-algebra. If we have functions f and g that have overlapping domains, then we can use common to both domains, the sum, difference, product, and quotient. Remember, if we're looking for the sum of f plus g, we just take the f of x plus the g of x. F minus g of x is just f of x minus g of x. F times g of x is f of x times g of x. F divided by g of x is f of x over g of x, as long as g of x doesn't equal 0. So let's just do a couple of those, okay? If f of x is 2x plus 1 and g of x is x squared plus 2x minus 1, find f plus g of x. Now remember, in our properties it said f plus g of x is really just f of x plus g of x separately. So we're going to take this and put it right here. So we know f of x is really 2x plus 1. And g of x is really x squared plus 2x minus 1. So we're just going to add two expressions, basically. So we end up with 2x plus 1 plus x squared plus 2x minus 1. We're going to combine like terms. We're left with x squared and 4x, because 2x and 2x is 4x. And this positive 1 and negative 1 are gone. So we're left with f plus g of x equals x squared plus 4x. All right, how about finding the difference? So if we're looking for f minus g of x, remember that on our chart it said f of x minus g of x is equivalent. So we know f of x is 2x plus 1. Now this is really important that we put especially the second function in parentheses because of this minus right here. We don't want to forget to distribute it. So make sure that you just are in the habit of putting a parentheses around it. And you've got x squared plus 2x minus 1 here. Now we're going to distribute this negative through. So we end up with a negative x squared, a negative 2x, and a positive 1. And this I'm just going to bring down. Now we're going to combine like terms. So we're left with negative x squared. 2x minus 2x is just 0, so it's gone. And then 1 plus 1 is 2. So we end up with f minus g of x is negative x squared plus 2. And almost the last one. It says find f times g of x. Sometimes it'll look like this. So remember, it's f of x times g of x. So we just plug it in. F of x is really x squared. G of x is really x minus 3. And then we're going to multiply them. We end up with x cubed. Remember, we're going to distribute. And 3x squared. That's our answer. And then we need to evaluate when x equals 4. So we're really looking for f times g of 4, which we know we just plug it into x every time we see x. So this is really 4 cubed minus 3 times 4 squared. 4 times 4 is 16 times 4 again. Should it be 64? Minus 3 times 16. 16 times 3 is 48. We get a 16. And then our last one, we're going to find the quotient, which remember, if we're looking for f over g of x, that's the same as f of x divided by g of x. So we're going to plug this in. This is f of x on top, g of x on the bottom. And actually, we can't do anything with this, so we're going to leave it just the way it is. But keep in mind, we need to look for the value of the domain. Okay, so what do we know about the domain? Well, we have to look at our functions to see what they can and cannot equal. We know at the top here that because it's a square root of x, the square root of x can only be greater than or equal to 0. It can't be a negative. So for this top piece, we know that x has to be greater than or equal to 0. But for this bottom piece, because this is where it gets tricky, we know that a denominator cannot equal 0, right? And it so just can't equal 0. So we need to know, where does 4 minus x squared equal to 0, so we avoid those values. So we're going to subtract 4 to both sides, divide both sides by -1, and we're going to take the square root to get x by itself. So we get x equals plus or minus 2. Now keep in mind, we don't want x to equal plus or minus 2, okay? So we're actually going to do this. We're going to do a big, like, doesn't equal. For the denominator, we can't have x equals plus or minus 2. We also know, looking at this, if x squared was any bigger than 4, it would become negative, and we can't have that. So we also know that x, so if I were to, I'm just going to make this visual for you. If on our number line, okay, here's 0, here's 2, here's -2, we know our values cannot be 2 and cannot be -2, right? But we also know our x value cannot be bigger than 2 and cannot be smaller than -2. So our x values on the denominator have to be in here. They have to be in between the -2 and 2. Okay, so the way that we would say that is we could say -2 is less than x is less than 2, or in interval notation, we would say parentheses -2 comma 2. Now for our overall domain though, we have to make sure that everything agrees. So remember this up here, it has to be greater than or equal to 0. But remember that only counts for this part of this graph. So that means anything that I could put in the bottom, I'm still not going to be able to do it because it has to be valid on the top as well. So the only part of our denominator, or excuse me, our domain that's going to work is this value for 0 all the way up to 2. So the overall domain of the whole function is from 0 up to 2, but not including 2. Okay, let's talk about compositions of functions. You've probably seen this before. Another way to talk about it is when we've got f of x and g of x, the f of g of x, you're going to be replacing that value of x inside of the f of x with that whole value of g of x. So basically, every time I see x in the function, I'm going to replace this whole thing with g of x, which is why they put it right here. Okay, and this is just a little visual of how the composition of a function works. If f of g of x is equal to f of g of x, we say it this way. Then when we put in x, we put it into g of x, and then we're putting g of x into f of x. So instead of going like that, we can go straight to f of g of x. So let's talk about that. Now, this is something that you have to be really careful of. You have to be really cognizant of what we're doing. We can't rush through this. So remember that f of g of x, remember that this is the outside function. So we're always going to write the outside function first. But instead of x, we're going to write it with parentheses. So every time I see x, I'm putting in a parentheses instead, okay? And then inside the parentheses, I'm going to be putting in the g of x. So here's my g of x, and I'm going to plug it in every time I see an x. So every time I see x, I'm going to plug it in right here. Okay? And basically, that's it. We've got the root of x minus 1. Now, keep in mind, this did have a domain on it, right, where it said x had to be greater than or equal to 1. And this also had a greater than and equal to 0 for that function. So now they want to know, okay, can we find f of g of 2? So basically, we know f of g is this right here. So we're going to say f of g, but this is going to be a 2 here. Well, we know that's just going to be the root of 1, which equals 1. Now, keep in mind, this was our input for f, so we have to kind of work backwards and make sure this is going to work. If a value of 2 was being put into g of x, this would work, okay? We also have to look at it here. If it was 2 inside the g of x, 2 minus 1 would be 1, and it would still work for that domain, so that works just fine, okay? So f of g of 2 is 1. But what about f of g of 0? So remember, we go like this, 0, minus 1. Now this is a problem, right? Because this input of x, if I were to check this domain here, it's not greater than or equal to 1. So we can't input it to this function because it doesn't meet the domain. So we would say this is an undefined function, or you could say it doesn't exist. Okay. And then this one here, we're just going to find the composition again. F of g of x. In that way, we're going to go f, which is the outside function, and we're going to write the x as a parentheses instead. The inside function is g of x. So every time I see the x in f of x, I'm going to plug in g of x into it. And then we're going to solve this. 4 minus x squared plus 2. Simplify it. So f of g of x is 6 minus x squared. Now, what about g of f of x? So it's just the same thing but backwards. This time, the outside function is g. So I'm going to look here at g of x. And I'm going to write it out using parentheses instead of the x. And inside the g of x, the g of f of x function, I'm putting in f of x. So we're going to go f of x goes inside every time I see an x. So we're going to go f of x is really x plus 2. And we're going to simplify this. Now keep in mind, this is going to FOIL here. So I'm going to give myself some more space. 4 minus, and we're going to FOIL this. I'm going to do it right here. And we got x squared plus 2x plus 2x plus 4. First, outer, inner, last. Keep that inside of a parentheses because that negative, we're going to distribute it through. We're going to go here, 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 and here. Oh, and we can combine these two. This can become a 4x. So we're left with 4 minus x squared minus 4x minus 4. And if we combine like terms, those cancel. Negative x squared minus 4x is our g of f of x. Okay. And then they want you to plug in x equals 0 and 1, but you know how to do that. We would literally just plug in a value of 1 here. So this is f of g of 1. We get 6 minus 1 squared equals 6 minus 1, which is just 5. Okay, so we're just plugging in values for that. We're not going to spend too much time on that. And then this one is finding the domain of the composite function. So again, we're going to look for that f of g. So remember, we're going to look for that g of x domain first. The f function is going on the outside. So we go x squared minus 9, and this is what we put inside of that x. So first things first, we have to look for that domain of g of x. We know that 9 minus x squared with a root, we can't have inside of the root be equal to 0. We also know that x squared can't be bigger than 9, okay? So we're going to set this equal to 0 to find out what the x cannot equal to. So we're going to divide everything by -1. We get x squared equals 9 plus or minus. So x equals plus or minus 3. So we know x cannot equal 3, cannot equal -3, and can't be bigger than it. So on a number line, it kind of looks like this. And that's our domain for g of x, right? So we know we have to make sure that the value for x here is between 3 and -3. So the domain of this is from -3 to 3. And that's it.